Afternoon, everyone, and welcome to the 8th installment in our webinar series. This month's topic is an approach to safeguarding construction and renovation operations. I want to start by thanking all of you for taking time out of your schedules to be with us here today. My name is Gary Paul, and I'm the Regional Sales Manager for the US and Canada here at Protectowire. I'm also a member of the National Fire Protection Association, Society of Fire Protection Engineers, and the Fire Suppression Systems Association. Today's topic is centered around NFPA-241 and the role of linear heat has taken within these applications. We'll be spending the next 30 minutes or so talking about various aspects of the NFPA-241 code and how the code governing construction and renovation projects has opened up a whole new market ideally suited for linear heat detection. Before we begin, I wanted to take a quick moment and highlight the topics of our webinar series to date. Since starting the series, we've covered a broad range of topics which are all listed here. Now, if you're new to our webinar series or want to catch up on any of our previously recorded webinars, you can find these and a lot more on our website at www.protectowire.com/resources. Construction and renovation projects are continuous and never-ending. As soon as one project hits the home stretch, another is just breaking ground. According to OSHA, each day, 6.5 million construction workers report to more than 250,000 job sites, and these numbers have been steadily growing at a rate of 4.5% per year. The NFPA has conducted back-to-back studies of the reported fires at these job sites between 2010 and 2014, and then again between 2013 and 2017. So both 5-year snapshots with a 1-year overlap. The study also included demolition projects, as NFPA-241 is also applied to these project sites, but for today's discussion, we'll focus our attention on new construction and major renovations as shown here. The first thing that jumps out between the two time periods is the fact that they remain consistent, with not much changing in any of the categories. There was an increase in the number of fires. Reported injuries between the two categories saw a decline, although not to paint a grim picture, but fatalities in renovation projects saw a sharp increase. Even reported damages on renovation projects saw a slight decline. The white elephant in the room is the reported damages seen on new construction projects. In this area, the numbers have almost doubled. I have no real insight into what this means. One possible scenario could be the size and complexity of these projects. Another could be the materials being used, which we'll get into shortly. And as we hop down the rabbit hole of facts and figures, the NFPA provides a further breakdown of the major causes of these incidents. And what do we learn? Well, apparently there's too much cooking happening on these job sites, as this is the #1 cause of reported fires in new construction projects. All kidding aside, we also see that it's the lowest monetary impact, so not really the culprit in the sharp increase we saw in reported damages. This just tells me there's a lot of bad cooks out there, and no one invited me to lunch. Seriously though, as we look down the list between the two categories, we see the major causes being electrical, heating equipment, hot works, and even arson. These areas have both the highest incident rate as well as the highest financial impact. Now, as we all know, construction sites are extremely active with a number of different contractors performing a variety of tasks. With this comes a number of challenges, including who owns responsibility for these safety plans on these sites. Is it the owner or the general contractor? Next, and these are in no particular order, another challenge would be the alarm system. The existence or lack of sprinklers, smoke alarms, and other life safety systems that are designed to safeguard these locations. In renovation projects, these systems are typically functional but disengaged, in areas being serviced anyway, to mitigate any kind of false activity. As I mentioned, there's a variety of tasks being performed, and maintaining the existing fire safety systems, or the life safety systems I should say, during the process is only setting yourself up for failure. Disengaging these systems not only saves from having to have trucks roll continuously, but it also helps to avoid further damage to any of the renovation work being done. In new construction, the conversation's a little bit more animated in what options are available. The current conversation centers around temporary sprinklers and how this can be employed. However, this presents a whole other level of issues depending on what climate you're in, and the challenges of keeping pipes from freezing in a temporary system. There are systems that will accommodate these climates, and then the question becomes cost. Next, the challenge is going to be the construction material itself. The type of material, where it's staged, as well as the location of dumpsters, all become areas of concern, which segues directly into the on-site activities taking place, because if proper care is not taken to make sure these combustible elements are out of harm's way, it's like rolling the dice and hoping nothing happens. And lastly, with the absence of any other available alarm system, security becomes a more valid concern. As we saw in this list of causes, arson ranks right up there. The most common answer to this is a dedicated fire watch, which again presents another set of challenges. With our distribution partners throughout the US and internationally, we get a unique view of the trends as they develop from region to region and how folks are trying to address these concerns. Priorities and focus vary from state to state and even from county to county, which is widely discussed and what is widely discussed and adopted as standard operating procedure in one spot is barely a blip on the radar for others. But one thing is certain, the conversation around NFPA-241 is growing and continually expanding. Just about every day we see news reports of a construction or a renovation project that's caught on fire with varying degree of damage. So with all these facts and figures, what are we talking about? With an average of more than 6,000 fires each year, we're looking at approximately 17 fires per day. Starting here with the most recent incident in Las Vegas, this actually occurred back in January, so a little timeline adjustment there. But as you can see here, these devastating fires take on a life of their own. This is an apartment complex under construction. Estimated damage to the facility is between 25 to 30 million, and the cause is still under investigation. And as you can see, these devastating fires are equal opportunity employers. They can happen anywhere to anyone, including iconic buildings like the Notre Dame Cathedral in Paris. As you can see, this occurred back in 2019. It was the famous Notre Dame Cathedral that was undergoing extensive renovations. Over 400 firefighters were involved in this incident. Of course, being the structure that it is, every effort was made to save the building. Damages were estimated at between 200 to 300 million euros, which is approximately 250 to 350 million US dollars. Cause of the fire in this case? Faulty wiring. And here in our own backyard in Waltham, Mass, back in 2017, apartment complex under construction, 5 buildings were involved, no sprinkler, were either incomplete or they were not in service. And this particular site had no NFPA-241 plan in place. And here, Overland Park in Kansas, 2017 again. Damages were estimated around 25 million. Cause of the fire was hot works. And I pulled this one on in particular because right from the AP states a huge fire at an apartment building under construction in suburban Kansas City has sparked fires several homes and blocks away, which just goes to show that we're not just concerned about the facility that we're working on, we're also concerned about the impact it's going to have in the surrounding community. As I mentioned a short while ago, the composition of the building materials presents its own unique challenges. Engineered lumber is being sought after more and more, with good reason. The advances in material sciences have produced a lighter, stronger, and more cost-effective solution to traditional steel and concrete structures. In addition to this, the wood elements provide the aesthetic appeal that many architects and building owners are seeking. According to the American Wood Council, tests of these enhanced building materials have produced some interesting results. In the state of California, nearly 80% of all public schools is wood framed. That's an estimated 320 million square feet that would traditionally be steel and concrete. Wooden structures have also passed FEMA requirements for safe rooms, which include withstanding 250-mile-an-hour wind tests and 100-mile-per-hour missiles, basically projectiles coming at the building. And tests have also been performed on 7-story wood structures to see how they would hold up under seismic activity. These structures have withstood 7.5 magnitude simulated earthquake test with almost no cosmetic damage. In 2019, the International Code Council approved a set of proposals to allow tall wood buildings as part of the 2021 International Building Code. Based on these proposals, the 2021 IBC will include 3 new construction types, including Type 4A, which covers structures up to 18 stories or building heights of 270 feet. This building also allows up to 972,000 square feet of allowable building area. Type 4B covers structures up to 12 stories and a building height of 180 feet with 648,000 square feet. And then there's Type 4C for structures up to 9 stories and building heights of 85 feet and 405,000 square feet of allowable building area. These new class types are based on the previous heavy timber construction type, which is now referred to as Type 4HT with this new release, but with additional fire resistance ratings and levels of required non-combustible protection. As a comparison, prior to this release, heavy timber, or Type 4HT, set the limits for wood structures of this nature at 6 stories and a building height of 85 feet and 324,000 feet. Just kind of gives you an idea of the advances these materials have provided. With the release of these new classifications, the aim is to mitigate instances like these. So, NFPA-241 was initiated back in 1938, right around the same time a clever industrial engineer set up shop to begin manufacturing a revolutionary new heat detector device. The current edition was released back in 2019, with the next release not expected until 2022. The code designates certain responsibilities to the owner as well as the contractors. These responsibilities are enforced whenever the building is under construction, renovation, or demolition. It requires the assignment of a full-time fire prevention program manager who is responsible for the development and implementation of the fire prevention plan throughout all phases of the project. And there are 2 different types of NFPA-241 plans. The first is the master plan, and then the second obviously being the project-specific plan. The master plan is developed by ownership, typically through contracted consultants, and addresses the responsibilities of the owner and general contractors as they relate to the project site. A project-specific plan is typically developed by the general contractor and is specific to the project at hand. Having a master plan in place ensures the owner's interests are captured, and having a project plan details the features of the program to be followed and includes such elements as fire department turnout information, logs and inspection forms, and any impairments or hazards that will be conducted while on site, as well as the typical floor plan. We're also seeing adoption and reference of the code in other codes. NFPA-1 states, all structures undergoing construction, alteration, or demolition shall comply with NFPA-241. The International Fire Code, Chapter 33, defers to NFPA-241 for items not covered by the chapter. And in the International Building Code, again, Chapter 33, covers safeguards during construction and also refers back to NFPA-241. NFPA-1 requires any structure undergoing construction, alteration, or demolition to comply with NFPA-241 and gives the AHJ the ability to require a documented plan be submitted. However, many jurisdictions either don't require a plan or don't realize that they can make it a requirement. Having a documented plan is the most practical way to ensure compliance with the standard and clearly designates the roles and responsibilities throughout the project. We're starting to see an increased awareness Here in the Northeast, the conversation's been ongoing for many years. And I'd like to give a special shout out to the Boston Fire Department in their efforts to raise awareness, not only to the merits of having some form of plan in place, but also some of the options that may be available to them. Here we see the BFD highlighting temporary detection and what the jurisdiction requires when using these systems. And in California, we're seeing that the Santa Clara Fire Department has amended the state fire code to mandate that any buildings in their jurisdiction over 3 stories be required to have a listed fire alarm system that includes linear heat detection during construction. So let's take a quick look into linear heat detection and how it's being used to address some of those challenges. Protectowire linear heat detectors are a series of fixed temperature devices. Their unique design enables their use in several challenging applications where conventional detectors simply can't reach. Except for fiber optic, Protectowire linear heat detectors are categorized as a digital device, which is simply to say the conditions of the device are either on or off. The first linear heat detector was invented back in 1938 by Gerald Holmes, the founder and original owner of Protectowire, and has been listed by both UL and FM since the 40s. Within the linear heat detection family, there are several options to choose from. To start, there's the PHSC series, which stands for Protectowire Heat Sensitive Cable. This is the product most widely used and the detector most relate to when they hear the name. Comprised of 2 steel conductors, the PHSC series can be integrated into any conventional or addressable system. However, there are limitations when considering equipment, which we'll get into in a few moments. Next is the PLR series, which stands for Protectowire Low Resistance. Same construction as the PHSC, the PLR series adds copper-coated conductors to reduce the cable's overall resistance value from 0.185 ohms per foot, which is the standard resistance value for steel, to 0.058 ohms per foot, which is roughly a 2/3 reduction in resistance value. Lower resistance equals longer runs. The most recent development in linear heat detection is CTI, which stands for Confirmed Temperature Initiation. Replacing the steel core conductors with copper and constantan creates a Type T thermocouple, providing the ability to measure physical temperatures at the location of the fault. Through the required CTM530 interface module, we can now program the initiation temperature and compare it to the temperature of the fault. Through this process, we can discriminate between a mechanical failure and an actual heat event. And lastly, we have fiber optic, which is widely viewed as the next generation in linear heat detection. Standard digital linear heat detection is considered a passive device, meaning that it sits in a ready state, waiting for the fixed temperature to be achieved before activating. Fiber technology is an active system that reports real-time temperature profiles anywhere along its length up to 10 kilometers or 32,000 feet. Off a single fiber and can be further segmented or zoned into 256 unique partitions anywhere along its length, which is all done through software. Standard operation of linear heat detection has 3 primary conditions: normal, open, and alarm. Normal conditions where the detector is energized and voltage is regulated through the end-of-line resistor, which is commonly referred to as a Class B installation. This can also be configured in a Class A, which I'll illustrate in a moment. Once energized, it's possible to detect an open condition. This typically occurs when the conductor is cut or the end-of-line resistor is disengaged. And finally, the all-important alarm condition. Once exposed to a heat event, the heat-sensitive polymers melt away to expose the inner conductors, causing the system to short and signal a relay back to the panel to initiate the sequence of events. For today's conversation, I'd like to focus on CTI, which is our acronym for Confirmed Temperature Initiation. As I mentioned before, linear heat detection is a passive, normally open digital contact device. Apart from an open fault, there are 2 conditions: on or off. The drawback to this is the fact that standard linear heat cannot distinguish between an actual heat event or physical damage. What this means is if the detector gets hit by a forklift or a 2x4 on the job site, you're going to initiate a false alarm. With CTI, we still have a passive digital contact device that's normally open. However, by changing the two primary conductors to the dissimilar metals of copper and constantan, we have what is commonly referred to as a Type T thermocouple. Through the required CTM530 interface module, we're now able to provide the ability to distinguish between a mechanical fault and an actual heat event. Given the fact that many existing alarm and suppression systems are disengaged to avoid false alarms, having a detection system specifically designed to avoid these situations is critical. As we illustrated with standard linear heat previously, CTI can register an open condition if the detector is cut or the end-of-line resistor is somehow disengaged. However, when the conductor is short for any reason, the required CTM530 interface module will first register a fault. The phenomena of a Type T thermocouple is that when these two dissimilar metals come in contact, they naturally emit a charge that is measured down in the millivolt range. This charge will then increase or decrease in direct correlation with the temperature surrounding it, like a digital thermometer. If the detector experiences a short, a fault will register on the interface module, as well as the exact temperature and location of the fault. This temperature is then compared to the initiation temperature requirement programmed into the interface module to determine whether an alarm condition has been met. If the temperature registered does not meet the initiation criteria, the module remains in a fault condition. The detector is still active up to and including the spot of the fault. In a Class B configuration, everything beyond the fault becomes a dead zone. The CTM530 interface module acts as the brain to providing us the ability to discern the temperature profile where the short occurs and determine if any further action is needed. Each interface module is capable of a single detection circuit, which can be configured for either a Class A or a Class B monitoring depending on the specific requirements. With CTI, because we're working with the similar metals, polarity becomes a crucial aspect. Reversing polarity induces what's referred to as a parasitic junction that will have a direct impact on the module's ability to accurately register the correct temperature. Through the interface module, we're able to support a maximum of 4,000 linear feet, including any feed cable, and this is an important distinction. And as I just mentioned how critical polarity is, the only feed cable allowed is the extension grade Type TX thermocouple cable, which we offer. The two dissimilar metals, copper and constantan, are the basis for our polarity concerns. The use of any other type of feed cable will have a direct impact and limit the system's capabilities. Per NFPA, linear heat is categorized alongside spot heat detectors. When it comes to listed spacing is 50 feet per UL and 35 feet per FM. So, now to illustrate how this may be laid out in a renovation project, here we see the linear heat winding its way through the facility. And you can see it here, this red line. This is one engineer's rendition of a project they had going on. As you can see in this example, we see the single run of detector making its way around the project. Now, depending on the ceiling height and the size of the rooms, this will determine how far apart the detector is required to be. But this is a very simplistic approach to providing heat detection throughout the facility without the need for conduit. And as this image shows, we're making use of existing supports to maintain adequate exposure to the areas being worked on. As we can see here, the existing system is disengaged and tied off, rendering the facility vulnerable. But as you can see, the manner in which it's applied, we're just loosely supporting this around the sprinkler pipes and other conduit in the area. We're running in and out of the various rooms as we were illustrating on the schematic before. So you have good temporary protection throughout the facility. You have easy installation, very cost-effective solution. The system is compatible with anybody's existing fire alarm control panel, and because CTI gives us that false alarm discrimination, it's ideal for these construction zones. Now, as I was mentioning, the CTM530 interface module is compatible with virtually any fire alarm control panel through 4C contacts and can be reused as projects end and new projects start up. The detector more often is scrapped during the cleanup, but it's possible, with proper care, to roll up the detector and reuse it for future use. As with any new installation, it's always recommended to test the detector with a fluke meter to make sure the length is free of any shorts along its entire length. And here are a couple more examples of installation approaches when working on a renovation project. The detector is loosely secured in place for easy removal when the project is complete. And here we also see a service coil. This may have been put in place to extend the zone into other areas as work progressed. These pictures illustrate some of the installation practices we preach during our training sessions. You never want to induce a 90-degree bend into the detector. This could induce a short. Rather, maintain a minimum of 2.5-inch bend radius will safeguard against this. As you can see here, this is a broad transition around the corners, nice sweeping arcs, no kinks. With its listed spacing and its ability to sense heat anywhere along its length, you can quickly see the benefits of using linear heat detection, and in particular CTI, in any construction project regardless of its size. And in closing, I chose this excerpt from a local contractor's website, and I think it speaks to the true intent of NFPA-241. Safety is everybody's responsibility. It's not about being compliant with laws or winning awards. It's not about meeting minimum requirements. It's about people, and it begins with people. I want to thank you all again for taking time out to join us here today. Hopefully the information provided was informative and brings about a lot of questions. As a quick reminder, any questions you may have can be emailed to us at info@protectowire.com. Also, don't forget to submit your vote on our polling questions and check out the offers provided under the offer tab. Again, my name is Gary Paul, and it's been my pleasure to speak with you today.